Hello! Today we are going to be talking about matching functions to their derivatives given tables of values of function and derivative. These problems are always about matching. What you do is you analyze the table that you are given and then you assess the answer choices to see which one has all of the same expected characteristics. To do this, we must understand the basic relationship between functions and their derivatives. Namely, if function is increasing, then the derivative must be positive. And if the derivative is positive, this also means that the function must be increasing. This relationship goes in both directions. And of course, this also implies that if the function is decreasing, then the derivative must be negative. On graphical side of things, if the function has an extreme value, a max or min that is not an endpoint, then it must be that the derivative is equal to 0 at that point. This is not going to work both ways, however. If the derivative equals 0, we can only say that the function has a horizontal tangent. This is not so important for us today. We are mostly going to focus on the increasing and positive, decreasing and negative relationship. So let us see how we can do this in an example problem. First example gives us table of value for derivative. Remember, for the derivative, we care if it is positive or negative. If derivative is negative, like here, we have decrease. If derivative is 0, we have neither increase or decrease. And for all positive values of derivative, function increases. So when we verify our answer choices, we look to see if we increase or decrease between values. To go from 10 to 9, we decrease, which means derivative is negative. 9 to 9 means we don't move at all. 9 to 12 means we increase, so positive derivative. And then again, 12 to 13 is positive. This matches sign arrangement of derivative values in table above, so we check other answers. Going from 10 to 10, we see no change. This does not match the fact that the derivative says we should decrease. B is wrong. To go from 6 to 0, we have decrease, but to go from 0 to negative 1, we decrease again, which does not match with our derivative above. For this table, negative 4 to negative 7 is decrease, negative 7 to negative 7 is 0, but negative 7 to negative 10 is negative again. This means that D is not the answer. Only one that fits is A, so A is the final answer here. The point is, you look at sign of derivative and you look at change or type of change in a regular f of x. Let's see what happens if we have a table that starts with regular f of x. For this table here, we see that we decrease, then increase, increase, increase. This means that our derivative will be negative, then positive, and then again positive. So we're looking to match the signs in the derivatives of our answer choices. In table for A, we see we start with positive. This goes in direct contrast with the table above, so A is wrong. In B, we have negative, but second value in table is negative, and we needed this to be positive, so B is wrong. C has positive to start. Once again, this is incorrect here, which means that D is probably the answer, but we're going to be careful and check. We see we have negative, followed by 3 positives. This matches table above, which means that D is correct. So this is it. In these types of situations, remember, when you are looking at the derivative, you only care if it is positive or negative because this will tell you if your original function is going to be increasing or decreasing between values, respectively. Likewise, if you are trying to discern information about the derivative given the original function's table of values, you'll look to see if it's increasing or decreasing between values because this will give you the most likely kind of sign that you can expect for the derivative at that value of x. If you try to get any more analytical than this, then you will more than likely get mixed up in these types of problems. So keep it simple. And this is everything I need to say to you today. Goodbye.